Subtracting whole numbers and decimals. We're now going to shift our thinking from addition to subtraction, and the question that was posted in class today is, why is it important to know how to subtract outside of math class? Some examples that you might have thought about would be with money again, just like when we add, because as we said before, you're not always going to have a calculator or a smartphone that has a calculator on it around. An example of when you might need to use the subtraction is, let's say you go to the store and you have a $20 bill and you are going to purchase a new shirt, and the shirt cost $15.29, and you just are curious about how much money you would get back. So you kind of do subtraction in your head or even on a piece of paper just to see how much it would be before taxes, of course. Another time you use subtraction in science class, if you were with Miss Green, she had you take a graduated cylinder and you took two different measurements and subtracted for the difference. You could use any kind of measurement differences just in the real world. You could also you can use subtraction for any kind of differences you're looking for. Perhaps you saw a movie on the pyramids in Egypt, and it told you the height of one of the pyramids and then it told you the height of another one, and you're just curious to see how much taller one of them is than the other, so you could do a subtraction problem. So anytime you're looking for the difference between two objects, maybe mom gives you one amount of money and gives your brother or sister another amount of money, and you realize, wait a minute, they've got a few dollars more than me. You are actually doing kind of a subtraction problem because you took their amount minus your amount to see how much more they got. So you probably have a whole bunch of different ideas, and these are just some to get you thinking. Now we're going to go into the steps for subtracting whole numbers. Just like addition, you want to line up your numbers based on place value. Next, you're going to subtract starting at the far right and moving to the left. And you may have to regroup if you don't have enough of a certain place. Humans are born with 350 bones. And as we grow, some of them fuse together. Adults only have 206 bones. So that's as an adult. So I would like to know how many more bones we have as a baby than we do as an adult. So when I want to know how many more, then I am looking at the difference between adults and children. So I would do a subtraction problem. Anytime you're looking at the difference between two things, whether you're looking at the difference in someone's height versus another height, and you want to see the difference between the two, that's when you will be using subtraction. So I lined up my place value. I have my ones, tens, and hundreds, and I'm looking at my ones. I have no ones, so I am going to regroup one of my tens and give that 10 to the ones place. So now where there was 0, there are now 10. And now I can subtract. 10 minus 6 is 4. And I moved my tens place. 4 minus 0 is 4. And really that's not 4 minus 0, that's really 40 minus 0. And then I moved to my hundreds, which is really 300 minus 200, which would be 100. So babies have 144 more bones than adults. You wouldn't think of it that way. You would think that adults had more because they're bigger body, but like I said, they fuse together. So that's a little bit of science for you. Subtracting decimals, you're going to follow very similar steps to adding decimals. Step 1, you need to line up your decimals. Just like we saw with that one example, if you don't line them up, you're going to come up with a completely wrong number. Once you line up your decimals, we're going to second step we're going to do is bring down the decimal or drop down the decimal and forget about it so that we can just subtract like normal. The third step is we're going to use our zeros to hold place. Very important subtraction so that you won't have the headaches. In step 4, we're going to subtract like normal. Let's do some examples now. If it took someone 7 8/10 of a second to run from one point to the next, and it took somebody else only 4.9 seconds, which is 4 9/10, we want to know how much faster that second person was than the first, because when you're running, the littler numbers are faster, right? So we're going to subtract to see the difference. So I lined up my decimals, and then my next thing was to drop down the decimal and forget about it. So I'm now just thinking about 78 minus 49. Okay, this is what I'm thinking. There's no zeros I need to put down because all my places have a match. So I'm okay on with my number of digits. There's 2 digits here, so 2 digits there. Now I may have to regroup if necessary. So let's go back to our notes. Subtract like normal, and for our 5th step, regroup if necessary. Alright, if we have 8/10, I cannot get rid of 9/10, so I'm going to have to regroup. So I'm going to borrow from the ones place, and now I only have 6 ones. I'm going to give that one that I'm giving, I'm cutting it up into 10 pieces and giving it, so now there's going to be 18 pieces. 18/10 minus 9/10 would be 9/10. 6 wholes minus 4 wholes would be 2. So that person was 2 9/10 of a second faster than the first person. When you are doing any kind of subtraction, because addition and subtraction are called inverse operations, that means the opposite can be done to check, we're going to use addition to check our work, because if we don't end up with the same numbers when we do the opposite operation, then we've done something wrong. So we will take our difference, which is 2 9/10, and we're going to add it to the 4 9/10, which we were trying to get rid of a minute ago with our subtraction, and we're going to drop down our decimal like normal, and we should get this beginning amount when we're done. So 9 9/10 is 18/10. You can't have 18/10. You have to regroup it to one whole. Here you have 7 wholes, so we have 7 8/10, which does in fact match what we started with. So subtraction and addition can be used to check yourself, check your work. And I want you to try doing that on everything that you do with decimals, because decimals are kind of tricky, so it's better to be safe than sorry and check your work. Alright, I'm going to have you try just a problem. I'm going to go into a word problem. 3 6/10 minus 1 5/10. Go ahead and pause me and try. Okay, so you should have dropped down your decimal. Forget about it. 6/10 minus 5/10 would be 1/10. 3 wholes minus 1 whole would be 2 wholes, so 2 1/10 would be your answer. To check my work, I'm going to add these two together. So 1 5/10, 2 1/10. I get 6/10. 2 plus 1 is 3 wholes, and look at that, those two match, so I am good to go. A few more examples, because there's a lot of things that can happen when you are subtracting decimals. Let's say I had 65 29/100, and I want to find the difference between that and 28 38 thousandths. Okay. I lined up my decimals like my first step said to do. Now I'm going to drop it down and forget about it. And now I have to put a 0 as a placeholder so that I can make sure all the digits are the same. There's 5 digits now here and 5 digits down there. This is what some of you will end up doing. You will try to do like this, and you will forget to put the 0 as a placeholder. You drop down your decimal like you're supposed to, and then you're just going to go through and say, oh, this must be 8, 9 minus 3, 6, 2 minus 0, 2. Here I'm going to regroup. That's 7 and 3. Now we're going to look at the difference between this and this, okay? When I put that 0 to hold my place, I now have something to subtract from. I have nothing there. Try and take away 8 thousandths from 0 thousandths. So I'm going to regroup. So now I have 10 thousandths minus 8 thousandths, which would be 2 thousandths. 8 hundredths minus 3 hundredths, which would be 5 hundredths. 2 tenths minus 0 tenths would be 2 tenths. Here I'm going to regroup again because I don't have enough. 15 ones minus 8 ones would be 7 ones. 5 tens minus 2 tens would be 3 tens. Do those two answers match up? No, they do not. And when I do my inverse operation, this is not going to add up to what I started with. So we're going to check our work. We'll do the 28 and 38 thousandths, which is this one, plus what we got as our difference. And we should end up with what's here. So 8 and 2 thousandths. Oh, sorry, forgot to drop down my decimal. 8 and 2 thousandths would be 10 thousandths. 5 plus 4 more in the hundredths place would be 9 hundredths. 2 and 0 would be 2 tenths. 8 ones and 7 ones are 15 ones, so I'm going to regroup. And then I have 6 tens. So this right here matches this right here. If you had done it with this, you'll see that it doesn't match. So we have our 28 and 38 thousandths. Add it to what we got as our difference there. Line up our decimals, drop it down. 8 and 8 thousandths is 16 thousandths. Regroup. We now have 10 hundredths. Regroup. We now have 3 tenths. Come over to the ones place. We have 15 ones. Regroup. And 6 tens. These do not match. Look at that. Whoops. And that are two different numbers. And you're thinking, well, they're not very far off. But it can mean a lot when you're working at a store. If you give back wrong change, even by pennies, your whole cash register will be off and you could get in trouble for that. If you're talking about the Olympic races, the swimmers, a few tenths of a second, a few hundredths of a second mean the difference between a gold and a silver, or even the bronze and not medaling at all. So you want to make sure you put that 0 as a placeholder.